Hello, Roger here with another Virtual Cities Unity3d tutorial. I believe this is number 7. And in this tutorial, we are going to generate costs for our residences based on their residence type. And then we're going to have the adults of the residences actually pay their monthly rent or monthly mortgage. So let's get started by first defining a public float attribute named monthly costs. So if they own the home, this would be their mortgage. If they're renting, this is their rent. And then we'll want to assign this randomly based on residence type. But to do that, we want to define some parameters that define the range for each type. And after thinking about it, I think the best way to do that is to come up with some static classes so that these values are locked across all the different residences and all the different scripts, so we can be sure that we're using the correct values. So let's go ahead and do that by doing public static class, and then I'm going to name this suburb costs. And then I can define a public static float named low, and I can put in the low costs. And then I'm going to create a public static float named low, and we can set it to 650F. So hard coding it right here on line 9 of the residence.cs script is the only way that this can get set. And then we can do public static float high equals, say, 2200. So for the apartments, let's do 550 to 800. And then for the condos, let's do 800 to 2200. And lastly, for the apartments, let's do 675 to 1000. Okay, so then we could actually use those values down here to generate a random monthly cost. So we could assign it as monthly cost equals, and I actually don't want to draw these from a uniform distribution. I want to draw these from a random distribution, so that the average cost would be the value that's in between, and then they would be less likely to be at the extremes. To do that, we can use Mathf.Lerp, and what this does is it linearly interpolates between the first argument A and the second argument B by t. So t is constrained between 0 and 1. So if it's 0, you get A. If it's 1, you get B, and if it's 0.5, then you get the value that's halfway in between. So A and B are pretty easy. We can do suburb costs.low and suburb costs.high. For the random value, that's something that we need a little bit of help with. So what we'll do is we will go to our scripts folder, and then we'll just create a script named miscellaneous. And to generate the normal random value, I actually have this set up already, and it's something I just import from project to project. It's basically a static class. It's called miscellaneous, or MISC, and it has one static method named normal random that returns a float, and you basically give it a mean and a standard deviation, and it gives you back a value from a normal distribution, a random value from a normal distribution with that mean and standard deviation. So with that defined, we can go back to residence, and then we'll want to do misc dot normal random, and in this case we want the mean to be 0.5 f, and for the standard deviation I'm going to put 0.25, and that way 0 and 1 will be at basically plus or minus 2 standard deviations. So it's pretty wide. We could even adjust this per suburb or per residence type if we wanted. So we have a monthly cost of $705 here and $609 there. $711. Might make sense to just round these. So those seem all pretty close together. That's kind of what we were going for there. Wow, there's a big jump there. Oh, they made it to the end. Alright, so it might be good at some point to go through and record those and see how many are actually at their extremes. And from that we could kind of tweak the standard deviation. Or if we can obtain housing data from, that would indicate appropriate standard deviations, we could go that route as well. So we're back in the residence script, and we want to set up a method that will take money from the adults in the residence and use that to pay for the residence. So let's set up a method. Process payment. And then what we'll want to do is subtract from our humans. So let's first go to the humans, and then we need to assign a value, an attribute value that can represent their wealth. So we can say public float wealth, and we'll just leave that at 0, so they'll start at 0. Wealth. So then inside of here, we can figure out, or we can divide the costs among the adults. So what we would want to do is var payment equals monthly costs divided by num adults. And then basically we can iterate through the adults and process the payment. So we can say for each, or let's do a regular for loop. It's actually a little bit more efficient. So do for int I equals 0, I less than num adults, I plus plus, and then inside of here I'll want to do adults at I dot wealth minus equals payment. All right, so now we need to figure out a way to run this method periodically. And the way that I'm going to show you how to do it is a little bit complicated, but in the long run it will make our lives a lot easier. And what I want to do basically is to set up time events so we can have events when the day changes or when the month changes or the year changes, or we could have like a bi-weekly event that might be useful as well. And we can essentially subscribe to those events. So we can say, we can just tell it ahead of time, when this event occurs, run this method. And it's really nice because it consolidates the event code to our time controller. So let's first talk a little bit about how we'll detect when the events change. So basically, we can detect whether the day changes if the value that's assigned to day is different from its old value. So for instance, we can create a int named, so for instance, if we create an integer named old day, then in update, before we go through and update these public attributes, we can say old day equals day. And then after we update these, we can do if old day does not equal day, then we've detected that the day has changed. It's that simple. So we could have, every single person, every single human could subscribe to an event that we define that would get raised here. That's sort of the game lingo, I guess. It would get raised. And then the humans could all do something. They could brush their teeth, or they could eat breakfast, or whatever it is. But what's nice is this is the only place where we have to do this sort of logic check. It also, there's lots of other advantages. I won't go on about it. I'll just kind of show you how to do it. Okay, so this is starting to get a little, well, it's not terribly complicated now, but I'll just kind of clean it up a little by adding some comments. So say time event, or I'll say code for time events. So we'll have old day, we'll have lots of others, but I'll fill those in. Let's just focus on detecting day changes for now. So we'll need to do public delegate void on day change handler. And then we can pass the day actually to the method that ends up handling the events, the subscribed events. And then we'll want public static event on day change handler on day with the lowercase change handler. Even if you don't understand this completely, it's okay. Once you kind of recognize the pattern, then and that's actually all I'm trying to explain. I'm just trying to explain the pattern so you can reuse it. All right, so this is how we know if our day changed. So that what we need to do is check whether this is null. So if no one has subscribed to this event, then this would be null. And that's why we need to do this. So if it does not equal null, then we'll essentially raise the event. and we're passing it the new day that was just assigned. So how would you use this? So we can set up a script to test this. We'll call it test time event. Alright, so what we'll do is format it, I guess. And then in the start method, we can subscribe to the event. So we'll need to subscribe to this public onDayChangeHandler object that returns an event, and it's a static method of the time controller. So we need to do timeController.onDayChangeHandler. We need to do timeController with a capital T dot onDayChangeHandler that little, and then we basically give it the name of the method that we want to run, and the method needs to match what's defined here. So the method needs to return void, and it needs to take an integer. It doesn't really care about the name of the integer, but it needs to take a single integer argument. So we could do void do something on day change, and then this needs to take an integer, and then what we can do is plus or minus, and then we're not actually calling this method, we just want to give this or add the reference to onDayChangeHandler. And then here we could debug log it, for instance. So we'll say test time event component got day change message from time control. Oh, yeah, this is getting too long. Okay. Plus day. Okay, so let's try this. Okay, to test this. Alright, to test this, we'll need to remember to create a create a game object that actually has our test time event script. And then we can go ahead and run it. And again, this should occur on day change. And we have test time event component got day change message 1. So I'm actually going to disable this. Alright, so I finished updating all of the methods. You know, it really only makes sense to have update methods for minute, hour, day, week, month, and year. Day of the week and day of the year don't make sense because they end up being redundant. Before we did not have week, so I've also added in week as a public integer to the time controller. So now we're actually ready to hook this up. So now that all these events are set up, all we have to do is go to residence, and then inside of the start method, we can subscribe to the event. So we can do this at the very end. And we'll just do time controller dot on. And we can see all of our events populated. So we'll want to pay monthly. So we can do on month change handler plus equals process payment. Oh, and then this needs to be set up to take an integer. So it's saying no overload matches what's defined in the time controller. So here I need to do int month. I guess that ends up not being terribly helpful in all cases, but that's right. Okay, so let's go ahead and see if this works. So basically what we should see is actually on the first state, it should take a payment, and then every month it should take another payment. So I guess actually in the first month it doesn't call the event because the old month is 0 and the new month is 0. Month is okay. So yes, it looks like it took out their mortgage. Okay, it looks like a month change, and we see that their wealth decreased. So there's one other tweak that we can implement before we end this particular tutorial, and that is we can build in an inflation, a cost inflation. So we can do public float annual cost inflation. And I'm going to set that to 0 by default. And then we can just compute this, or compound this monthly. So then in here, we can increment the monthly costs depending on the inflation. So this would be times equals 1f plus divided by 12, because there's 12 months in a year. Alright, so now we go back to here. On the residence script, we should see a drawer or a slot where we can change the inflation rate, and there we go. So we could actually keep it at 0 for the suburbs, but then for the apartments, for instance, we could set this at 0.1. I suppose you could also set this up to handle the cost of inflation by apartment type, and that would make it easier to change them globally, so you could use like a static class for that. In retrospect, that's probably the better option, but I guess I already changed them all. You would probably be a lot less likely to miss something. So I was thinking we could have a higher rate of inflation for this one. So what if this was, well, for testing purposes, let's say, what if this was 30%? And then we can modify this to calculate the average wealth of the inhabitants of each residence type. So their average wealth is all 0 because a whole month hasn't elapsed. Alright, so a month a month went by. So I'm going to go ahead and run this again. Oh, so it actually appended instead of clearing these out. So we can actually fix that by, so we have this list of population data and we need to clear this. So when we run the analysis, when we push the button, we jump into here, and then we can do population datum.clear. Alright, so let's call that good. Thanks for watching, and the goal is to build up to incorporate jobs for our humans, since they have to pay rent now.